we are going to discuss about angle of minimum deviation in the case of a prism. A light that is incident on a surface of prism undergoes refraction at both surfaces of the prism and is deviated from the original path that was supposed to follow. There is a deviation in the path of the beam of light due to refraction from the faces of the prism. The angle of deviation is the angle between the original path that the beam should have followed and the deviated beam, or it can be defined as angle through which the incident ray gets deviated when passing through a prism. So if there is no prism, the light might have gone straight. In the figure you can see. Because of the prism, it is taking refraction to surfaces and finally emerging out. So the deviation of the incident ray from the actual path to the refracted path is called angle of deviation. If the prism is not there, it might have gone straight. But because of the prism, it is coming out, emerging out. Now, the angle between these two rays or paths is called deviation, angle of deviation. This minimum deviation is achieved by adjusting the incident angle until the ray passes through the prism parallel to the bottom of the prism, provided that it is an equilateral prism or the principal section of the prism forms an isosceles triangle. In these two cases, if you see at the minimum deviation, the refracted ray inside the prism will be parallel to the base of the prism. That is very important for doing the problems in the competitive examination. If the incident light beam is rotated in either direction, the deviation of the light from its incident path caused by the refraction in the prism will be greater. That means at the minimum deviation position, for that particular angle of incidence, the deviation will be minimum. But for any other angle of incidence, even though deviation is same, we will have two angle of incidence. That minimum point of deviation is called angle of minimum deviation. This can be observed by a small demonstration here. Here we are rotating physically the prism and we are using here a laser beam, a red color laser beam, and on the screen we are seeing that the light ray comes to one point, again comes back. Where it is just turning back is the position of minimum deviation. So instead of going forward, it is changing the direction. That point is called the deviation, minimum deviation position of the prism. That can be demonstrated by this. See, when we are rotating, the image is moving towards the right side. At one point, it is not going further. It is just coming back. That position where it is just turning back is the position of minimum deviation for the given prism and for the given color. A beam of white light falls on a glass prism. The color of light which deviates the least or passing through the prism is, we want to know. Here, when white light is falling on a prism, it splits into its composite colors, which is called dispersion. This was observed by Newton. It is VGR. And which is having more dispersion? Violet color is having more dispersion. Red color is having less dispersion. Very important for 2 marks and other competitive examinations. Here we are going to further discuss about the deviation also. The violet light has maximum refractive index and least speed when traveling through a medium. Since it has the shortest wavelength, thus it bends most upon incidence and has maximum deviation. So because of minimum wavelength, shortest wavelength in the visible region, violet color, it is having maximum deviation. So violet color has maximum deviation and also maximum dispersion. And which color is having least value? Red color is having least deviation and least dispersion, which you can observe by seeing the figure or diagram also. Very important for competitive examinations. The angle of minimum deviation is inversely proportional to wavelength of light. The angle of minimum deviation will be greater for color of having minimum wavelength. The angle of minimum deviation will be greater for the color of light having minimum wavelength. That is nothing but violet. The violet color of light has minimum wavelength. Therefore, violet color of light undergoes maximum deviation when white light passes through the prism. You see, what are the applications of this particular thing? The red color scatters the least by air molecules as it has greatest wavelength in the visible region. Scattering is inversely related to the fourth power of wavelength of the color. Very important for competitive examinations. That is why we have given here scattering and wavelength. How they are related? Scattering is inversely proportional to fourth power of wavelength of the color. So red light is able to travel longest distance through the fog, rain and air particles. That is why the red color is used in danger signals. See here, we have given a picture. The red color is used as a signals because it travels long distance, because scattering less, deviation less, dispersion is also less. So a person can see longer distance. Similarly, on a rainy day, foggy day, you can see in the figure the yellow lamps are used. The fog lamps are which color? Yellow lamps, because we cannot use red color as fog lamps because it is a stopping signal. That is why the car headlights in the foggy days we use on rainy days yellow color lamps as fog lamps because it has more wavelength, less scattering, less dispersion, less deviation, and road can be seen very clearly at these conditions. Similarly, yellow lights are used as fog lamps in vehicles on foggy and rainy day because for more wavelength and less scattering. So all these pictures are giving a clear visual picture for you, understanding that wavelength is more, scattering will be less, dispersion is less, deviation is less. So what are the applications? Red color is used as signals, first one. Second one, yellow color is used as fog lamps. That is application because of this property.